Hello, welcome to next session. In this session, we'll solve some questions of machine design. The topic is brake. Question number one is a block brake shown below has a face width of 300 mm and a mean coefficient of friction of 0.25. For an activating force of 400 Newton, the braking torque in Newton meter is, so this is the brake shown, this is 200 mm, this is 400 mm, this is the activating force 400 Newton, and diameter of the this block is your disc is your 300 mm, this distance is 500 mm, 150 mm. So options, we have to find out the braking torque. The options are A 30 braking torque in Newton meter, A 30, B 40, C 45 and D 60. Okay, and the direction of rotation is given as clockwise. Okay, so this is your schematic figure. So as block and brake are in contact at this point, so the normal reaction on the brake will be, so this Rn is the normal reaction on the brake, this part brake shoe. Okay, Rn, okay, will be Rn. Okay, as this disc is rotating or drum is rotating in clockwise direction. Okay, so it means this shoe is shoe will have relative motion in a direction anti-clockwise as compared to this drum. So we are considering the forces on this shoe and on this lever. So Rn is the normal reaction on this shoe. So as this shoe is rotating in anti-clockwise direction with respect to drum, or we can say the drum is rotating in clockwise direction with respect to brake. So the force of friction on the brake, we are considering force of friction on the brake on this part will be in this direction mu Rn, or in the direction of rotation of drum, or we can say it is in the direction of relative motion of brake, in a direction opposite to relative motion of brake with respect to drum. Okay, so the motion of drum is clockwise as compared to brake, and so the motion of brake will be anti-clockwise with respect to drum. So the force of friction will act in a direction opposite to that of motion or relative motion, so that will be this direction mu r. So this is the force of friction, this is your normal reaction. Okay, so now this is a schematic figure, and this 400 Newton has to be applied, so we have to find out the braking torque. So to find out braking torque, we will take moment about this point, hinge point. Okay, so as the diameter of the brake drum is your 300 mm, and this distance is also distance is 150 mm, so the mu Rn will pass through this hinge point. Okay, so there will be no effect of friction force on the moment. Okay, so the moment will consist of only uh, 400 into 600, activating force into the distance 600, and this is your clockwise, and Rn into 200, that is anti-clockwise. So from this we can find out Rn comes at 1200 Newton. Okay, so this Rn is 1200 Newton, and the force of friction is given by mu Rn, and coefficient of friction is given as 0.25. So this is the friction force is 1200 into 0.25, that is 300 Newton. Okay, so friction force is your 300 Newton. Okay, so mu Rn is your 300 Newton, and if we multiply by radius, this friction force, if we multiply it by radius, then it will give friction torque, so 300 into 150 by 1000, or 45 Newton meter. Converting this 150 into meter, that is 150 by 1000. Okay, so the friction torque will be your 45 Newton meter. So answer is option C. Okay.